So this is from Mihir. Any specific features that you look into to understand degradation patterns of batteries? And his follow-up is, or actually like extended question is, can you predict with some fidelity about micro short circuits or lithium plating related sort of stuff?
Okay, I can take this up. Mihir, since our approach is mostly data-driven and less physics or empirical-driven, we don't get into don't get into the details about if it is related to lithium plating or if it is a micro short circuit. Instead, our approach is to, because I'll explain why. It's because if you get into this physical layer or chemical layer, then you have to take into account all the differences in chemistries and all the differences in how the batteries are configured and assembled. And there are so many different types of batteries, different chemistries, different makes, different cells, that it becomes very complex. The advantage of using data analytics, especially using data-driven modeling, is to get to a higher level. On a higher plane, you can figure out patterns in degradation without having to go into this detail. So when we use neural networks for estimation of degradation, or we use other empirical methods for this kind of analysis. Those at that plane, the underlying stuff about plating or about short circuits, those are abstracted. And on that higher plane, where the neural network is trying to figure out the different weightages for different components, like the curves for current or voltage or temperature, then it can develop the model out of these raw data. And then at this higher plane, you can apply it to any battery, any chemistry, and it will work. You'll need to retrain the model for different chemistries, but mostly you are agnostic of the chemistry or the cell model and the cell make. So our approach is to build that data-driven model, and hence we don't get into this detail. But we can predict the overall degradation and the causal factors. That is still the outcome of the model.
Right. Yeah, I guess that definitely makes sense. At a very core level, every component would probably get. I mean, if there is a failure, then it gets looked into in extreme depth at that hardware level, and that's true even for ICE applications right now. So, okay, I think let me see. I think Mir has. Again,
I
I'm
can.
sorry for going further, but Mir has one follow-up. He says, how difficult is it or tough is it to understand uh, or compare field data, so that's at a system level, versus lab data, which is at again a component level? How difficult is it to compare?
Looks like Mihir has a lot of on-ground experience. Yes, Mihir, that lab data is completely different from the actual on-field data, both in terms of the data quality and in terms of the sheer number of parameters that you can capture in the field. So to give you a quick example, if you are dispatching into the grid, then you have the grid market prices or the load forecast. And the lab data, there's no such thing. It's only the battery being cycled under different conditions. So understanding field data is actually easier compared to understanding lab data, because there you can do multivariate analysis. You have the entire picture of how the system is behaving under different conditions. Lab data tends to be more simple, but because of its simplistic nature, the result that you derive out of it are also less useful. So I would say it's more fun to use field data compared to lab data.